Sup coders, it's Coderman here. Today I've decided to do something a bit different. Instead of doing my voiceovers real time while coding, which actually turned out pretty hard to do, I'm going to do my thoughts afterwards. So let's see how we go. I've started a new .NET Core 3.1 console app project. We're talking EFCore performance today, so let's install it as a NuGet package. I've got a blank canvas here, so I need EFCore connected to a database and saving some data. I'm going to create a work order model, which will be inside my database. Well, it'll be a table inside it. Now I need the DbContext. This is what I'll actually use to save my work orders. Inside the DbContext will be a DB set of work orders. I realized here that my work order model needs to have a key ID field, as well as the table attribute to work. A quick tip here, when Visual Studio doesn't recognize a class, press Ctrl plus full stop and it will suggest imports like you see here. Make sure you name the table. I prefer to use the name of with the model, just to protect myself if I decide to rename it in the future. I decided I wanted to use the DbContext options builder rather than configure my connection inside the DbContext itself for whatever reason. So I generated the constructor, which allows me to pass through the DbContext options. Lucky me. So I just wanted to use an in-memory database, but realized halfway through it's not going to work with what I wanted to show you. So this is just me failing. Watch it. Watch it. But first, to really demonstrate anything, we're going to need some data. I created a simple for loop which creates a bunch of work orders. I also wanted to simulate some data going into the work order description, so I made a quick and simple random string generator using the random class. As you can see, I was experimenting with IntelliSense to try and figure out how to generate this random content. Experimentation is one of the most important things to being a good programmer. You can't just try one thing and give up and ask someone. You gotta go and find a solution, and then even better than that, go out and find a solution that you actually like. So we've got our data, we're adding it to the work order DB set, and persisting those changes with our save changes call. I add a stopwatch to time and compare the different methods of using a DbContext I mentioned earlier. I then gave it a quick test to make sure everything was working as expected. After having a quick look at what sort of content my random string generator was making, I decided I just wanted to make it bigger because, bigger is way better. It was at this point I realized I will need to use SQL Server after all. Like I stated earlier, the in-memory database isn't going to cut it. So first I added EFCore, SQL Server, the SQL Server NuGet package, and created a function which generated a SQL Server connection string, and started splitting my code into two main functions, without and with performance enhancements. Now you can see what sort of data is being generated. It's definitely not English, but it'll do the job. At the time of writing, I actually realized now that I've passed a seed to the random class, which actually means it's all the same data. Whoops. In order to demonstrate my performance example, I needed to simulate some data being added to the DbContext over a long period of time. So I have a for loop, which calls on my without or with performance enhancements method. I wanted to make sure the database was empty as well before running any tests on it. This method of deleting entities works, but it has a huge performance overhead of having to load each individual entity into memory that you're deleting. Notice how with each iteration, the time it takes to perform the same work goes up and up and up and up. Have a look at the memory usage here. No memory is being released, so everything just keeps getting slower. Now it's time to demonstrate the correct way to use a DbContext. I copy my without performance enhancements method and rename the copy to with perf enhancements. Let's examine the method and what I'm changing. This method loads all the work orders into the DbContext in batches. In between each batch, I might want to run some extra code on the work orders, and if that code errors out, I want everything to be discarded and not saved to the database, which is why the save changes occurs outside of the main loop. Here is the problem. Instead, we'll create our own separate concrete connection to the database and start a transaction. Then inside the batch loop, we'll create and dispose of the DbContext. Now we can call save changes every iteration and maintain a healthier memory usage, but also get the advantage of rolling back our transaction if something fails and protect our database from incomplete data. I walk so you can run. Make sure you open your connection and set the DbContext's current transaction to yours. Otherwise, you may find yourself alone in the woods with only this error to comfort you. Anyway, after the loop has completed, you also have to commit the transaction, otherwise we're basically coding a fart. Now, take a look at this beauty. It's taking less time to complete the work between goes, the memory usage is less like Everest and more like your walk to work. So, let's go back to the old method to compare results, shall we? Remember when I said my method of deleting entities works, but has a huge performance overhead? This is what that looks like. Simply incredible to witness, I know. A much more memory efficient and faster way to empty a table is to write the SQL yourself. I couldn't be stuffed to use SQL command, so I quickly installed Dapper and used its execute method. Now you can see it just cruises on through to immediately demonstrate the memory inefficient way to use DbContexts. And that's all I have for today, folks, so I'll see you next time. Catch ya!